Hello, this is part 2 in our video lecture series on the Michael reaction. And in this video, we're going to look at what happens if we try to cross a Malonic Ester synthesis with a Michael reaction. Okay, and what's going to happen is we're going to form delta keto acids. And so this is essentially, it's almost the same reaction as the Malonic Ester synthesis, except when we saw the Malonic Ester synthesis before, we had an alkyl halide as the electrophile. In this reaction, we're going to have an alpha beta unsaturated carbonyl or a Michael acceptor as the electrophile. Okay, so you can see here I have diethyl malonate or malonic ester, and it's reacting with methyl vinyl ketone, a Michael acceptor. And then we start with sodium methoxide, maybe an ethanol, and then we have a second step where we've got H3O+, H2O, and heat. And you can see what I've generated here is this compound. You can see it. Where I've got a carboxylic acid. Let's try this here. And a ketone in the molecule. And their relationship is this. So carbonyl carbon, alpha, beta, gamma, delta. Okay? And so it's a delta keto acid. Okay? So I'm going to give you not a complete mechanism, but I'm going to kind of break down the steps, kind of like we did with the Malonic Ester synthesis. Alright, so we're going to start with diethyl malonate. Remember, it has these very acidic hydrogens in the middle. It has a pKa, I think, of about 11. Okay, here is my ethoxide base. We can do a proton transfer. And that generates a Michael donor. So the conjugate base of diethyl malonate can act as a Michael donor. And then we can react that with a Michael acceptor. Alright, and we do a nucleophilic addition step. And that gets us to somewhere. Can you see that? Carefully. Ooh. Okay, so you see I've got this enolate here. All right, and then we can pick up a proton from ethanol. Proton transfer. All right, and that gets us, oops, should be an OET. And we've got a new bond there. Okay, and this completes the Michael part of the reaction. And you can see, but at this point I've set up my alpha, beta, gamma, that delta keto relationship. Okay, however, this is not a carboxylic acid, this is a diester still. So this is where the hydrolysis and decarboxylation parts of the malonic ester synthesis come into play. Okay, so now we're going to add H3O plus, H2O, and heat. And the first thing we're going to do is an acid catalyzed hydrolysis of these esters. So that's going to turn them into carboxylic acids. So we'll come back up here. And now we're looking a little bit more like our final product. This is actually a good review of the malonic ester synthesis. Okay. And then if we continue heating this, we're gonna lose CO2. We're gonna do it that decarboxylation, and we'll essentially lose this part here. Okay. So there is. Again, let's kind of review our Greek alphabet. This really isn't an organic chemistry lecture. This is it's an organic chemistry, or a Greek letter lecture here. Okay. So alpha, beta, gamma, just kidding, delta, keto acid. All right. And so that's going to conclude this kind of part 2 lecture on the Michael reaction. The next lecture is actually another kind of application of the Michael reaction. So, all right, thanks for watching.